Picture a modern factory floor. A worker steps into an aisle just as an autonomous mobile robot, or AMR, is rounding a blind corner. It halts just inches from their legs. In 2026, the most dangerous robot isn't the one that's fast, it's the one you assumed was safe. This is your practical field guide to navigating that new reality. We are going to look at exactly how US factories keep humans safe around industrial robots, cobots, and AMRs, using modern ANSI and RIA safety expectations, all without sacrificing productivity. For decades, safety meant a bolted steel fence. Now those physical cages are gone. Humans and multi-ton machines operate in the exact same shared spaces, which leaves zero margin for physical error. A robot's motion is no longer a predictable repeating loop. It is entirely software-defined. These machines rely on live sensor data and AI path planning to navigate, meaning the level of risk in any given area alters in real time based on what the robot perceives. And because these robots are mobile, the hazards are no longer stationary. A risk that didn't exist 10 seconds ago can suddenly appear at a blind corner, a busy intersection, or right in the middle of mixed human traffic. Without a steel perimeter to protect us, the safety protocols themselves must be engineered directly into the shared environment and the software running the machines. To govern these uncaged environments, the industry relies on three major regulatory frameworks: ANSI/A3 R15.06 for fixed robots, ANSI/RIA R15.08-1 for mobile systems, and the International ISO 10218 standards. This pyramid diagram shows a strict hierarchy of safety controls enforced by these documents. At the base, engineering controls, like software limits and laser scanners, must take absolute priority over administrative rules or personal protective equipment. That hierarchy brings us to a crucial point. Collaborative is not a type of robot, but rather a verified mode of operation that requires specific controls. You cannot just slap a warning sign on the wall and call it a day. The true source code of modern robot safety is a continuous, task-based risk assessment that analyzes every possible human interaction. To achieve compliance under these new standards, facility operators have to treat behavioral software rules with the exact same rigor they used to apply to welding steel fences. For a fixed robot to operate safely alongside a human, that continuous assessment dictates it must use one of four distinct, verifiable modes of collaboration. This top-down graphic illustrates the first mode, the safety-rated monitored stop. In this mode, the robot completely halts all motion the moment a human is detected entering its designated zone, and only resumes when they leave. Second is hand guiding. This allows an operator to use specialized manual controls to physically lead the robot's motion through a cask, like teaching it a new weld path or inspecting a part. Third is speed and separation monitoring, or SSM. Here, the robot uses 3D vision or radar to continuously calculate the human's distance, dynamically slowing its own speed down as the person approaches. Finally, there is power and force limiting, or PFL. This mode uses built-in torque sensors to restrict the robot's kinetic impact, ensuring that any incidental physical contact remains well below human injury thresholds. Selecting and verifying the appropriate collaborative mode for a specific task is the only way to balance high factory floor productivity with guaranteed human protection. But those four modes apply to fixed robots. When we look at the R15.08 standard for industrial mobile robots, the complexity scales up. Because the machine moves, its safety zones have to dynamically travel with it across complex, shared floor plans. This radar graphic illustrates how an AMR handles the detection zone. This is the outer perimeter where the machine first identifies a potential human or obstacle using laser scanners, allowing it to initiate a safe speed reduction. Inside that is the protective stop zone. If an obstacle breaches this critical inner radius, the AMR must trigger an immediate halt to prevent any physical contact. Facility managers also have to map out strict no-go zones and crossing zones. Blind intersections where human and robot paths overlap are the highest risk areas for mobile machinery. Because that safety perimeter dynamically travels with the robot, facility-wide traffic management becomes just as critical as the hardware sensors mounted on the machine itself. So how do these abstract standards hold up on a real factory floor? Let's run a rapid-fire knowledge check to see if your facility is actually compliant. Question 1. Can you remove safety fences just because a robot is labeled collaborative? False. The entire application must be verified first. Question 2. Which safety controls come first? Engineering controls always beat out administrative rules or personal protective equipment. Question 3. Which mode uses distance to dictate speed? That is speed and separation monitoring. Question 4. What is the most dangerous situation for an AMR? Navigating blind corners without right-of-way rules. Question 5. What happens when you update a robot software? You have to completely revalidate the safety parameters. Question 6. Does an emergency stop button replace proper safeguarding? False. An e-stop is a backup, not a primary preventative measure. Question 7. Who owns the safety liability? It is a shared responsibility between the manufacturer, the system integrator, and the employer. Question 8. What is a safety function? It is a formally verified risk reduction control, like a laser scanner. Question 9. How do you secure an AMR crossing? Through strict traffic management and validated facility sensing. And question 10. What happens if you add a sharp tool to a force-limited Cobot? You instantly break the safety assumptions of that mode and have to engineer entirely new controls. Passing a modern safety audit means mastering these specific, interactive edge cases. You cannot rely on outdated assumptions of safety when the machinery is constantly adapting. To bring your floor up to standard, plant managers need a practical protocol they can execute on their very next shift. This checklist is your Monday morning blueprint. 1. Map every human-robot interaction point. 2. Verify your safeguarding layers are functioning. 3. Document any changes to the software or the workspace. 4. Train your staff on the exact modes being used. And 5. Implement a strict stop work rule if any safeguard is ever bypassed. If you want to learn more about workplace safety and OSHA rules, subscribe to HSE Study. In the era of intelligent automation, replacing physical cages with rigorous, continuous validation is the ultimate safeguard for human life.